We are now starting question number 10 of this P1 paper of 2023, May, June. The diagram shows a part of the curve with the equation y is equal to 4/2x minus 1 whole square, and a part of the lines x is equal to 1 and y is equal to 1. These curves passes through the points A, 1, 4 and B as 3/2 and 1. Find the exact volume generated by the shaded region, which is rotated about 360 degrees about the x-axis. So this is the original figure of that curve, which is shown in the diagram. This is x-axis, this is y-axis, and the curve is like this. It is passing from this point A, 1, 4, and this point B, it is 3/2 and 1. This is the line x is equal to 1, and this is the line y is equal to 1. And this is the region which is being shaded, for which we are going to get the volume of that figure there. But we know that we can get the volume which is generated by pi y square d of x from A to B limits. This is the volume due to x-axis of that solid which is being obtained from this figure there. So we know that we are going to get the volume of this figure from 1 to 3/2 of this whole shape minus this volume of this line cylinder obtained with respect to the y is equal to 1. So your actual volume will be equal to the whole volume, which is equal to pi 1 to 3/2 is the limit y square. So from this, y square is equal to 16/2x minus 1 power 4. So it will be 16/2x minus 1 power 4 d of x minus pi y is equal to 1. So y square is equal to 1. So that thing is equal to 1 into d of x again from 1 to 3/2. So total volume from 1 till 3/2 of this whole figure minus the volume of this small patch, and this is the total volume of the required region for the shaded part of this curve there. Now this volume will be equal to pi as it is into integration from 1 to 3/2, 16 as it is there, and 2x minus 1 power minus 4 d of x minus pi as it is 1 into d of x from 1 to 3/2. So this volume will be equal to pi 16 as it is 2x minus 1 by applying the integration formula. This is minus 3 into the derivative of this 2x minus 1 is 2 there, and the limits are 1 to 3/2 minus pi as it is 1 integration is x, and the limits are 1 to 3/2 there. So this will be equal to pi into minus 8 over 3. And now you put the limits on this portion there, which is being obtained as into, if you put the upper limit, it should be equal to 2 into 3 by 2 minus 1 power minus 3 minus 2 into 1 minus 1 power minus 3 minus pi as it is 3 by 2 minus 1. So we can write this thing as pi as it is minus 8 over 3, 3 minus 1, 2 power minus 3 minus 2 minus 1, 1 power minus 3 minus pi, take the LCM, it would be 3 over 2. So this value will be equal to pi as it is minus 8 over 3. 1 over 2 raised to power minus 3 will become 2 raised to power 3 minus 1 over 1 raised to power 3. That means what? 1 minus pi, it is 1 over 2 there. So this value will be equal to pi as it is minus 8 over 3 into 1 over 8 minus 1 minus pi over 2. This value will be equal to pi as it is, this 8 and 8 cancel, minus into minus 7, that will become plus 7 over 3 minus pi by 2. And finally, this value will be equal to 3 to the 6. It is pi 14 minus 3 divided by 6, or it is equal to 14 minus 3 is 11 pi over 6 is the final answer for this volume of this solid. That is 11 over 6 pi cubic unit for this area of the region which is bounded by the curve y is equal to 4 over 2x minus 1. Now part B. A triangle is formed from the tangent to this curve at the point B, the normal to this curve at the B, and the x-axis. Find the area of that triangle. So for this figure, we are going to draw the two triangles there. One with the help of this right angle triangle, tangent there at the point B. So this is the tangent there at the point B. And normal to this curve at B is like this. So this is the triangle being formed by these two positions. And you are going to get the area of this triangle there. Because this is tangent there and this one is the equation of normal to that point there. So first of all, y equal to 4 into 2x minus 1 power minus 2. So the gradient of this curve dy by dx is equal to 4 into minus 2, 2x minus 1 power minus 3. into the derivative of that thing, that is 2 there. So 4 2s are 8 2s are minus 16 into 2x minus 1 power 3. That is dy by dx for this general curve of this equation there. And now you are going to find out at the point B. B point is 3 over 2 and 1 there. So m is going to be as equal to dy by dx. So that thing is equal to minus 16 into 2. X value is there 3 by 2 minus 1 power minus 3. So this thing will be equal to minus 16 into 3 minus 1 is 2 there, minus 3. That is minus 16 over 2 power 3, which is minus 16 over 8, and that thing is equal to minus 2. That is the slope of this tangent to this curve is minus 2 there. Then the slope of this equation of this tangent there is equal to y minus y1 is there 1 equal to m, that is minus 2, into x minus x1, that is 3 by 2. So this will become y minus 1 is equal to minus 2 into 2x minus 3 over 2. And since this tangent is going to be cutting the x-axis at this point C there, so the coordinates of C, because at the C position y coordinate is 0, so 0 minus 1 is equal to this minus 2 and 2 cancel, minus 1 into 2 into x power is 3 by 2 minus 3. So this 2 and 2 cancel. 3 minus 3 is 0. Sorry. So y is 0 there. Minus 1 is equal to minus 1 into 2x minus 3. So minus and minus plus. So 1 is equal to 2x minus 3. So 2x is equal to 4 or x is equal to 2. So the coordinates of C there is 2 and 0 there. Now, finding the equation of normal. So for equation of normal, y minus y1 is equal to minus 1 over m into x minus x1. Y minus 1 is equal to minus 1 over minus 2 into x minus x1 is 3 over 2 there. Again, it is cutting at this point D there, where y coordinate is 0. So you will find the x coordinate of this point there. So this minus and minus positive. So y coordinate is 0 minus 1 is equal to 1 over 2 into x minus 3 over 2. This 2 is going to be cross multiplied. So minus 2 is equal to x minus 3 by 2. X is equal to minus 2 plus 3 over 2. That is minus 4 plus 3 over 2. That is equal to minus 1 over 2. So the coordinates of D there is minus 1 over 2 and 0. Now you have to find out the area of this triangle BCD. So for this area of this triangle BCD, is equal to half into base into height, because it is a right angle triangle there. So this BC is the base and this BD is the height of that triangle there. So B coordinate is 3 by 2 and 1. C coordinate is 2 and 0. And D coordinate is minus half and 0. So BD will be equal to 3 by 2 minus 1 by 2 plus, so 3 plus 1 minus 0 square and whole square root. So BD will be equal to 3 plus 1, 4 over 2, 2 square is 4 plus 1, or that thing is equal to root 5. Then you are going to get the values of BC. B is 3 by 2. C coordinate is there minus 2 whole square plus 1 minus 0 is this. So this thing is equal to 3 by 2 minus 2, 3 minus 4 over 2, 1 over 2 square plus 1 square, or that thing is equal to 1 over 4 plus 1. That thing is equal to 4 plus 1 root 5 over 4, and that square root is 2. So we are going to find out the area of this triangle BCD, which is equal to half. Base there is equal to root 5, square root of 5, and height there is square root of 5 over 2. So this thing will become 5 into root 5 is 5, 2 into 2 is 4. So area of that triangle BCD is basically equal to 5 over 4 square unit for this triangle there. So this is a complete solution of that problem number 10 of this paper 1 for this non-calculator paper there.